So,
Cool.
so far we were trying to find the derivative of the sine function with the limit definition. So we were doing the limit h tending to 0 of sine of x plus h minus sine of x all over h. And we used the sum of angles identity to break things up. And then we regrouped the terms so that we had the limit h tending to 0 of minus sine of x plus sine of x times cosine of h all over h plus the sine of h cosine of x over h. And then we factored a sine of x out of the first thing. And so now we're sitting at limit h tending to 0 of sine of x times the quantity 1 minus times the quantity -1 plus the cosine of h over h plus sine of h over h cosine of x. And now we're kind of left with this, but I can't get the h's out thing. Okay, so looking at this first piece, what happens when h's, like where does cosine go as h tends to 0 basically?
Cosine of 0 is 1.
So this turns into
1.
1
Which is taken away.
minus 1.
0.
Okay, good. So I'm still in a 0 over 0 case here, right? Let's see. And on the other side here,
Cosine.
I'm in a
Sine tends to h. That's going to be 90. That's going to be 0.
Yep. So I've got sine of 0 over 0 should be 0 over 0, right? So I'm still sitting in this kind of indeterminate form, right? Okay. Now, we need to break out a little bit of the definition of radians here.
Okay.
So if I want to know about the sine of h over h, I'm looking at a triangle, right? So here's an angle h, and sine is this side. Right? And I'm assuming this thing lives in the unit circle, right?
Right.
Okay, so this is the radius 1, which means that this arc length here is also h.
Okay.
So as I shrink that angle, this arc length and this vertical are really pretty much the same distance. See that?
This arc length and the vertical?
Yeah, so the vertical displacement is sine of h,
Right.
and this arc length is h,
Okay.
using the arc length formula for radians,
Right.
which is why this derivative only works in radians.
Okay.
So as I crank down on the angle, right, that's really what this limit h tending to 0 is doing. The quantity sine of h over h is the percentage longer this arc length is than the vertical. And I think that goes to 0, right, for kind of obvious reasons.
Yeah.
So I think this piece is 1. And now if I think about this one, cosine of h, right, is going to go to the horizontal, right, which is going to become the radius. And so this piece, my -1 plus cosine of h over h, is going to go to 0. Because that's the difference between cosine and 1. So as I crank down on this, I think that's going to 0 faster than the angle. So I'm going to get a 0 out of that piece.
Okay.
So ultimately here what I get is that the derivative with respect to x of sine of x is, this will 0 out, this whole thing is 0. Whole first term's gone. And the second term turns into
Cosine of x.
cosine of x. So the derivative of sine is cosine.
Cool.
There's maybe a little more hard geometry you could do here to actually firm those estimates up. This is just sort of the hand-wavy version. But a little bit more geometry it gives there.
I was imagining it as like the sinusoidal wave. Like
Yeah, so what this means is that if you have that sine wave, that this and x are basically the same thing. Right. So this actually gives you a nice tool that you can use later on, which is that sine of x is x for small x.
Okay.
Like extremely small x. Really, it's approximately x.
Mm-hmm.
And this estimate doesn't get good until the angles get small. But when you get down to, keep in mind, this only works in radians again.
Right.
So when you get down to 1/10 of a radian or 100th of a radian, this is right, sine of 100th of a radian is basically 100th. And you can play with a calculator to see that that's true.
Cool.
Cool. And that's really just this vertical thing and that arc length are pretty much the same as you get small in scale.
Okay.